This example is on finding the areas by integration. So to find the areas by integration, we'll need to do two different ones for this one here. So we have to find the area of the shaded region as shown in the given diagram. Here's one shaded region and here's the other shaded region. We will need to split this into two different questions since one is above the x-axis and the other one is below. So the function is x squared minus 4. So we need to integrate x squared minus 4 dx. Now we're going to have to integrate it first of all between 2 and 1. And then we're also going to have to integrate it between 4 and 2, since one is above and the other is below. So first of all, we're going to integrate this one. So it's going to be the integral. So it's x cubed over 3 minus 4x. We're going to find the answer between 2 and 1. And then we're going to do the same thing. So it's going to be the same integral. And this time it's going to be between 4 and 2. So looking at this one first, it's going to be 2 cubed, which is 8. 8 divided by 3, so it's 8 over 3. And then it's minus 4 times 2. So it's 8 over 3 minus 8, which is minus 16 over 3. And then we need to put the 1 in, so it's going to be minus whatever the answer to this question is. So it's 1 cubed is 1, and then it's a third minus 4. So a third minus 4 is going to be minus 11 over 3. So that's one part. And then for the other part, it's going to be 4 cubed over 3. And then minus 4 times 4. So the answer to that part. So it's going to be 16 over 3 for the first one. And then it's minus the area of the second one. We've already calculated that, which is minus 16 over 3. So then it's going to be 16 over 3 plus, minus by minus is a plus. So that part's going to be 32 over 3. This part over here is going to be minus 16 plus 11 over 3. So it's going to be minus 5 over 3. Now the thing is, since we're talking about the area under the curve, that's why it's a negative answer. So it's going to be a plus. We have to take the absolute value of that since we're talking about area. So your answer is going to be 37 over 3. And you can write your square units at the end. For the second part of the question here, it says find the area in the region bound by the curve and the line. Now, drawing out a rough example of what this would look like, we would first need to factorize this here, minus x squared plus 5x minus 4 equal to 0. We can actually change the sign of everything to make it a bit easier for ourselves, but we just know the curve at the end is an n-shaped curve. So it's going to be minus and minus. So our x's are going to be equal to 4 and the x is equal to 1. So they're the 2 points that the curve crosses the x-axis. And then what we also need to find out is the point where these two cross over. So in order to do that, we need to put one equal to the other. So it's going to be minus x squared plus 5x minus 4 equal to x minus 1. And then it's going to be minus x squared plus 4x minus 3 is equal to 0. Change the sign of everything just to make our factorizing a bit easier. And then we have 3 and 3, 3 and 1, x and x minus minus. So x is equal to 3 is one point where they cross over, and x is equal to 1 is the other point. So to draw a rough diagram here, we can actually figure it out. 1, 2, 3, 4 is all we need. It is an n-shaped curve. So that's the 2 points. So this is the point 1 and this is the point 4. And then we also know that the line goes through here and it also goes through this point. So we can actually just draw that one in there as well. Now it's said what we're trying to find the area of the region bound by the curve. So it's going to be looking for this one here. What we would need to do is find the area of the curve between 3 and 1. And we would also need to find the area of the line between 3 and 1 and take one answer away from the other. So we need to, first of all, we can integrate the curve. So minus x squared plus 5x minus 4 dx. We can integrate that between 3 and 1. So the integral of that is going to be equal to minus x cubed over 3 plus 5x squared over 2 minus 4, and integrate that between the values of 3 and 1. And then separately we need to find the integral of between 3 and 1 of x minus 1 dx. So the integral of that one is equal to x squared over 2 minus 1x between 3 and 1. Now, don't really have enough room to show you all of the workings here for this one here, but if we integrate this, we will get, when I sub the 3 value in for the first one, my answer is going to be equal to 3 over 2. Then I sub the 1 in the second time, it's going to be minus, so it's going to be minus by minus is a plus, which is 11 over 6. And then for the second one, we're going to be taking away the answer for this one here. So the answer for this one is going to be, again, 3 over 2 for the first one, and then plus half for the second one. And now if we take both of these away from each other, our answer is 4 over 3 square units. Third example we have here is the diagram on the right shows a sketch of the function. In the shaded region, represent the area bounded by the curve and the axis between the lines x is equal to 3 and x is equal to 1. And if the line x is equal to k, so this one here, divides this area into 2 equal portions, we have to find the value of k. So the first thing we would need to be doing here is finding the integral between 3 and k, and finding the integral between k and 1. We know that the two integrals between those values are actually equal to each other, so then we would need to go down that route to be able to find our value for k. So we're looking for the integral of 2x to the power of minus 2, and then the same one here. Now the reason why I've done that, it just makes it much easier for us to integrate, and then just have our little dx in the end. Okay, so to find the integral of this one here, it's going to be 2x to the power of minus 1 over minus 1. Now it's up to ourselves if we want to simplify that a bit, we can. So that is equal to essentially minus 2 over x. And then this, you're finding the integral between 3 and k. And then we're going to do the same for the second one in a second. So it's minus 2 over 3 minus 2 over k. And then the second one, it's going to be, we're finding the same thing. We're going to find it this time between the values of k and 1. So the first one we put in here is k, so it's minus 2 over k. And then it's going to be minus 2 over 1. Now we know both of these are equal to each other, so I can just make them equal to each other. So I'll make an equation out of it. So it's going to be minus 2 over 3 plus 2 over k, and that is equal to minus 2 over k plus 2. And then I'm going to try to solve for k from this. Best idea at the start is to probably multiply everything by 3k to get rid of any fractions. So if I multiply this one by 3, so it's going to be minus 2k plus 6 is equal to minus 6 plus 6k. Take my k's to the same side, probably easier if I take them to the right hand side to keep them positive. And then 8k is equal to 12, so then we have k is equal to 12 over 8, which is equal to 3 over 2.